Okay, welcome back for part two. If you haven't already watched part one, you should do that. This is part two where we're going to um, draw out some more complex Karnaugh maps to simplify some more complicated Boolean expressions, but none of this will make sense if you haven't watched part one. So let's get started with part two. Okay, let's create a Karnaugh map for the three parameter table A, B, and C, and we want to find a Boolean expression that will yield the results shown here in column E. We don't know what that is, but we're going to find out. So for a three parameter map, we're going to have 5 columns and 3 rows. Our last parameter is parameter C, so we'll have the negation of C and C in our 2 bottom rows. And we have to have all the combinations of A and B in our 4 columns. But be systematic about this so that we're following the right order here. We'll start out with the negation of A and the negation of B. Now we'll keep the negation of A, but we'll change the negation of B. Remember, as we have adjacent columns, we never want to change more than one parameter at a time. Now we'll keep condition B and we'll change negation of A to A. So we have A and B. And that leaves us with only one more change to make. We'll keep condition A and switch back to the negation of B. There's 8 spaces on our table, and those correspond to the 8 rows on our Boolean table. All right, now we have to be careful to transfer the results from our original Boolean table over to our map. Let's start in row 1. In row 1, we have conditions A, B, and C, and our outcome there is a 1. So A and B and C, that's going to be the third column. Row 3, that outcome is a 1. In row 2, we have conditions A and B, but not C, and that's an outcome of 1. So A and B, but not C, will have an outcome of 1 as well. Row 3, we have condition A, but not B, but we do have condition C. So A and not B with condition C has an outcome of 1. And right above that, we have conditions A but not B and not condition C, and that's going to be an entry of 0. Row 5, no A, but we do have B and C. The negation of A with B and C, that's an outcome of 0. Row 6, we don't have A, but we do have B, and we don't have C, and that outcome is 0. Row 7, no A, no B, but we do have C, and the outcome is 1. So no A, no B, but we do have C, the outcome is 1. And in our last row, negation of A, negation of B, and negation of C with the outcome of 0. There, we filled in our complete table. Our goal now is to group together all the ones with as large a rectangles as possible. There's really only one good way to do this. We can see that we have these two ones grouped together. And along with that, we have a 1 over here, which we can wrap around and group with the 1 over there. Now, what do those groupings have in common? The ones in blue have in common the fact that they are in column AB. So there's the first term in our expression. Or we could be in the red grouping. Now, the red grouping, what do they have in common? They have parameter C in common, that's for sure. But they also have something else in common. Do you see what it is? Since they're next to each other, they'll also have a column parameter in common. And they both share the negation of B. A changes between those two, but the negation of B is the same. So we have the negation of B and C in this case. And you're done. In order to get the results we want out of column E, the simplest way to do that, the simplest Boolean expression is AB plus not B, C. And we're done. Now I want to explore this wrapping idea just a little bit more. Why is it that we can wrap around and pick up on one end of the table and the other? Well, because we have to make the table flat because that's what we draw on, but in reality, we could represent that kind of like a checkerboard, and the edges can be wrapped around, and after that, the ends can be wrapped around so that every square is adjacent to every other square. And so by wrapping around, we're just acknowledging that our table could be wrapped up to make opposite edges connected, and even the ends can be reconnected. Okay, let's do one more, and then I'm going to give you one for practice. Let's create a Karnaugh map and find the simplest Boolean expression to achieve the results for column E. Once again, 3 parameters here, A, B, and C. So we're going to have a 5-column by 3-row table. All right, we don't need the box in the top left. Our last parameter is C, so we'll have the negation of C and C in our 2 rows. And then again, the same order, negation of A and the negation of B. The negation of A with B, A and B, and A with the negation of B. Okay, let's fill in those values. Row 1, conditions A, B, and C give an outcome of 0. So A and B and C give an outcome of 0. Row 2, A and B, but the negation of C gives an outcome of 0. Row 3, we have A but not B, and C gives an outcome of 1. A but not B with C gives an outcome of 1. A but not B and not C gives an outcome of 1. Row 5, we have not A, B, and C. That gives an outcome of 1. Not A and B and not C gives an outcome of 0. Row 7, not A and not B, so we're finally in our last column. If we do have C, we have an outcome of 1. And if we have not A, not B, and not C, we also have an outcome of 1. So we've filled in our map. Now we just need to loop some ones together here. Take a look at that and see if you can spot what your largest groupings of 1 would be. First of all, we have a couple of ones together over here, but don't stop with that. Let's wrap that around with these ones over here on the right, and we have a large grouping. Now, what does that grouping have in common? That grouping of 4 doesn't have C in common. It crosses over the negation of C and C. It doesn't have A in common because it crosses over A and the negation of A. But that grouping of 4 does have the negation of B. That's what all 4 of those have in common. So that grouping says that our expression will start with the negation of B. That contains some of our outcomes. Or don't fall for the temptation just to group this one on its own. It's really not next to many ones, so we have to go to this one to the left. Then we have a grouping of 2 instead of a grouping of 1, and that's better. That makes for fewer switches or fewer parameters. Now, what do those 2 ones in the red box have in common? Well, they clearly have parameter C in common, but they have something else in common. What is it? They both have the negation of A. So our other condition here is the negation of A and C. And so the simplest Boolean expression that will yield the 1s and 0s shown for E is the negation of B or not A and C. And we're done. All right, this one's for you. Take a minute, use a Karnaugh map to write the simplest Boolean expression that yields the ones shown in column E. Pause the video, go ahead and do that, and unpause when you're ready to see the solution. Okay, well, any 3-parameter map, A, B, and C, is going to start out with a table of the same basic design. So what will our outcomes look like? And you might notice that we fill the table in the same pattern all the time because that's the beauty of having the same table and following the same truth table. Okay, so if we have parameters A, B, and C yield an output of 0. A, B, and C yield an output of 0. A and B, but not C, yields an output of 1. A but not B with C yields an output of 0. A but not B with a not C yields an output of 1. Row 5, we don't have A, but we do have B, and we do have C. That outcome is 0. If we don't have A, but we do have B, and we don't have C, we have an output of 0. If we don't have A or B, but we do have C, we have an outcome of 0. And if we don't have A, B, or C, we do have an outcome of 1. So there's our 1s. Now, of course, those 3 are connected, but we can't group together a group of 3. We can only group together groups of 2, 4, or 8. And so we should definitely loop these 2 together. Now, what do they have in common? They have the negation of C in common, but they also have parameter A in common. And so that looping is represented by A and C naught. Additionally, we can loop this one over here. We don't want to ever group something by itself unless we absolutely have to, but we can loop that around with this one over here. And what do those 2 have in common? Well, again, they have the negation of C, but they also have the negation of B. So we can be in the loop for A and C naught, or in the loop for B naught and C naught. So the simplest Boolean expression that will give us our results is A and not C, or not B and not C. And we're done. Okay, let's do one last example. Let's look at a 4-parameter map. We want to find all the conditions on A, B, C, and D this time that yield some Boolean expression in simplified form for the outcomes in column E. Well, it's really about how we set up our table. So we saw this earlier, but we're going to have the following table established. We have the same 2 parameters in our top row where we cover all the outcomes for A and B. But since we have a 4th parameter, we combine it with C in the left column, and we have not C, not D, not C, and we'll change parameter D. And we'll change parameter C to get C and D, and our bottom row is C and not D. So there are 16 rows on our Boolean table, and there are 16 spaces on our map. Let's fill those in. Row 1, we have A, B, C, and D, and the outcome is 0. A and B, C and D, and the outcome is 0. Row 2, we have A and B and C, but not D, and the outcome is 1. So we're still having A and B and C, but not D. That's down here, and the outcome is 1. Still with parameters A and B, but not C and D, and our outcome is 1. And still A and B, but no C and no D, and our outcome is 1. That's in our top row, and there we go. And here again, you can really see the value of being organized. If we group all of our 1s and 0s the way we always have for truth table, that makes it much easier to fill in our map. Okay, row 5, we have A, but not B. That means that we're going to be moving over to this column over here. If we do have C and D in that column, our outcome is 0. A but not B with C but not D, our outcome is 0. A but not B, not C and D, and our outcome is 1. And A but not B, not C and not D, and our outcome is 0. And at that point, we're half done. Row 9, no A, but we do have B. So now we're in that column. No A, but we do have B, and we do have C, and we do have D. The outcome is 0. No A, but we do have B. We have C, but not D. Our outcome is 1. No A and B. No C and D. Our outcome is 1. Okay, we're almost done. For the bottom 4 rows on our table, we have no A and no B. That is to say the negation of A and negation of B, but we do have C and D, and our outcome is 1. No A, no B, and C, but no D, our outcome is 0. No A, no B, no C, but we do have D, and our outcome is 1. And our last row, no A, no B, no C, no D, and our outcome is 0. So we've got our table filled in and we're ready to start looping. Make sure that you agree with all those results and rewind and watch that again if you're not so sure. Okay, how can we group these together? Well, it takes a little bit of practice to spot the biggest loopings that we can come up with, and sometimes there's more than one way to do this. Start by looking for the biggest possible groupings. Are there any groupings of 8 that you could put all together? There are no rectangles that contain 8, so then we should start looking for groupings that contain 4. There's an entire row of 1s right here that we could loop together. In addition to that, there's a couple of 1s down here which we can actually wrap around and loop together with those 1s in the top row, so there's a grouping. And that takes care of almost all of our 1s. But there leaves one lonely 1 right here in this box. Now we don't want to ever circle anything on its own unless we absolutely have to, and we can do better than that. We can't go down or to the right or to the left, but we can group that one with the 1 above it. There, and we've grouped all of our 1s together. So let's go back to the big blue rectangle. What do those parameters have in common? Well, they go through all the combinations of A and B, but they have in common the negation of C with D. But our 1s can also lie in some other loops. Let's take a look at our red one. What parameters do our red grouping have in common? Well, everything that's in red has parameter B in common, but red also goes through the bottom row and the top row, which means it has parameter not D in common. So the red grouping takes care of all the B and not D combinations. And that leaves us with that little green rectangle. What did those have in common? Well, those green entries have in common the negation of A and the negation of B, but they also have in common parameter D. And so our third place that we could have 1s would be in the negation of A and the negation of B and D. And that is our simplified Boolean expression. So the simplest way to achieve the outcomes of column E would be the negation of C and D, or B and the negation of D, or negation of A, negation of B, and D. Okay, 4-parameter maps are as complicated as we're going to get in this course. It gets a little bit tricky unless we get access to more dimensions. It's possible to do K-maps for more parameters than that, but it gets much more difficult. So we're going to stop right there. At this point, you'll be given an assignment to correspond with this unit that's given in Blackboard. You should go ahead and do that. We'll do a little review of this when we return to class. And we'll look at one more topic related to Boolean algebra, and that's going to be the end of the unit. So make sure to stop by the Math Center if you have any questions, and we'll see you soon.